Greetings, Internet Scholars. This is your Jesse Stiles. Welcome to a very special episode of Twisted Signals. In the next few videos, we're going to do some examples of data sonification, generating sounds from data sets and messages that we get from the web. And we're going to be doing this using Node.js inside of Max. So let's go over to Max and we're going to make a new patch. And, full disclosure, your Jesse Stiles has never taken a proper computer science class in his life. I am very much self-taught when it comes to writing code in things like JavaScript and Python. So if you're a formally trained computer science person, I apologize in advance if I'm using terminology that is different from what you've learned in your class. And, maybe you have ideas for ways I could do things more efficiently. If you notice anything like that, please do leave a comment in this video so that we can all get smarter. All right, so Node.js, this is built on JavaScript. It allows us to create JavaScript applications that run on our computer, and it's very easy to add in packages that give us access to various web APIs. So it's a great way to get data from the internet into our computer, and in this case we're going to get it into Max where we can create sonification patches. The object that can run Node.js code in Max is Node.script, and Node.script requires a JavaScript file in order to do stuff. So if we just make a Node.script object in our patch, we're going to get an error and it's going to be grayed out. So let's make a new folder for this project and we're going to put everything in that folder, the Max patch and the JavaScript stuff. And this first demonstration is going to be sonification of weather data. So let's go ahead and save this Max patch onto the desktop in a new folder, and we're going to call this weather sounds. Let's go into the folder, and the Max patch will also be weather sounds. I'm going to use an external text editor to make my JavaScript code. I am using Atom, which is a free open source text editing application. So we'll make a new file, and let's save this into the same folder. So weather sounds, we already have weathersounds.maxpat. We'll make this weathersounds.js. This is our JavaScript file. And in our JavaScript file, for starters, let's just load the Max API. So we'll create a const called Max API, and we will require the Max API, which is written like this. And we'll put a semicolon at the end of that line of code. And then once we do that, we can use the Max API to do stuff like create an outlet and then send some message to that outlet. Okay, so that is weathersounds.js. Hopefully I didn't boop it up. Let's go back to Node.script and tell it that we want to use this newly created JavaScript file. And we're going to also use an object that is associated with Node.script called Node.debug, which if we connect it to this right outlet here, is going to let us know if there's any bugs in the code that we're trying to run here. Script start should start this JavaScript. And theoretically, this is going to send a message out the first outlet. So let's just print it with a printer, and I'll also make it pop up. All right, so hopefully when I send this message, we're going to see the debugger telling us that it's running, and we'll see the hello world message printed. Hooray! Okay, everything's good. We loaded the Max API, the debugger is happy, and we successfully sent hello world out this outlet. Let's now get this piece of JavaScript to interact with the patch in different ways. we can actually get back to our text editor by double-clicking node.script now that it's associated with this JavaScript file. You just want to look at your preferences. If you're using an external text editor, you can specify the one you want to use in Max in the preferences. You can say always use text editor, and then you can choose the program right here. I've chosen Atom. So when I double click this, it's going to open up in Atom, which is super convenient. So we're going to make a function that can respond to messages from Max, and we do that by saying max.api add handler. And our function is going to go inside these parentheses. The first thing we're going to say is the first part of the message. So let's just say it's test. And then we'll say a comma, and then in parentheses, rest of the stuff we want to expect in the message. I'm just going to leave that empty. And then we will make a big arrow and some squiggly braces. And inside of the squiggly braces is the function. So let's just respond to the word test by sending another message to the outlet. We'll say, yes, nice test, good job. Let's not use a comma, just like that. Okay, and going back to our Max patch, our code is still running. It still says hello world when it starts. Hopefully we can send it this message and get a response. Great. So it understands this message test, and it just sends out this kind of canned response. Let's make another function that could maybe do something useful. Like if you wanted to do math in JavaScript, we could say, we'll make a new function named add, and then it's going to be followed by some values, a and b. And then we can make our response to that a plus b. Let's save that, go back to our patch. Let's restart it. So it says hello world, the test still works, and if we say add 5, 6, it adds them. We get the result 5, 11. And we could update this to do whatever. We could multiply them. And we need to restart the script, and now it multiplies them. So by the way, if you want to save yourself a little time, we can say auto start 1 and watch 1. This is going to make it automatically monitor the JavaScript file and re-invoke it whenever it's been updated. And auto start just starts the script as soon as this patch loads. So if we went back here, and let's add the 2 numbers and then add 5 more. We got 5 plus 6 plus 5 gives us 16. Okay. So this is the most basic thing we can do. We just made a Max patch that loads a JavaScript file, and it's running that JavaScript. This is not yet doing any of the cool stuff that Node.js gives us, which is all these packages that allow us to interact with things on the web. So to do that, we need to, first of all, make sure we have Node.js installed on this computer. So Node.js install, if you just look for it, you're going to find installers here. So you can install Node.js on whatever platform you're using. We are on iMac, and on our computer, we're going to go into the terminal, and we're going to go into the folder that we created for this project. Okay, so I have navigated into my desktop, and this is my folder with my stuff in it. So let's move into the folder named Weather Sounds. And if we say ls, you can see we have our 2 files in here. I have Node already installed on this computer. You can check that you do it by just doing this command, and it'll tell you the version of Node.js that is installed. And if you have Node installed, you will already have NPM, which is the Node package manager. And we can tell NPM that we want to create a new NPM project in here. And there are a bunch of questions we're going to be asked, and I'm just going to hit enter to all of these to give me the default values. So this has generated for me this new JSON file, which we can look at in Atom. So this is the name of the project. It found the JavaScript file. Cool. The NPM package that we are going to use to get weather data into this app is this one. It's the Open Weather APIs. So we are going to tell NPM that we want to install this package. So back in my terminal, I'm going to say npm install Open Weather APIs. And if we look in our folder, we have a couple new things. We have a package lock.json, which describes the packages we're using. And we have a new folder, node modules. And we've installed Open Weather APIs and whatever dependencies that it requires. So let's look at the documentation for this package to see how to use it. So we're going to load the package kind of the same way we loaded the Max API. And then we're going to have this new method, weather, where we can set things and get data. One thing about a lot of these APIs is that you are going to need to create an account with them and then get some kind of key or token that allows you to interact with their API. So this is using openweathermap.org, and you can see the link that you go to where you can create an account and then get the credentials that will allow you to interact with the API. So I've already done that. I'm logged in here with my account. And I can see my API keys. So your API keys are going to look like this. It's just going to be a big string of numbers and letters. So let's just copy all this example code and paste it into our JavaScript file. So I'm going to make this a const just to be consistent with what I did up here. Const weather, and then we're going to open this API. You can set your language. Let's make this English. And then there are a bunch of different ways that you can set the location for which you will be receiving your weather data. So you can set the name of the city, or you can say latitude, longitude, coordinates. Cities have IDs. You can also set the zip code. You can set the units that you're going to use. So that would be Celsius. I think this is Kelvin, and then this is Fahrenheit. And then here is where we're going to specify the app ID. So you would want to go get your own unique key to do this. I am going to use one of the keys that I already generated here. So let's go in here, and we're going to replace this with our unique key, and it's going to be in quotation marks. So let's comment out these methods of setting the location. And we're just going to set the zip code, and let's set it to Pittsburgh because that's where we are. Let's go ahead and just save this and make sure we're not getting any errors. Back in Max, we're able to start it, we're able to say hello, and we can still add things. Great, so no problems yet. Let's look at how we can actually get some weather data now. So here are some functions that would get things like the temperature, the pressure, the humidity, a kind of linguistic description of it, or we could just do this and get all of the weather data in a kind of JSON formatted method. Why don't we try that? I'm going to copy this. get all the JSON file returned from the server, rich of info. Now, the example here is going to be printing this data into the console log, but because we're doing this in Max, let's actually send it out a outlet in Max. So when we do this, we should do all the things we did before. We're going to load the API. We're going to say hello world. If we send it test or add, we get those functions. And then we're adding the weather API. We're setting a location and some units. We're providing our credentials. And then finally, we should get all of the weather in a JSON format. So let's save this file, go back to Max. And if we look at what got printed out, it said hello world because it does that at the top of the code. And then it prints out this dictionary. So that is the information in a JSON format. And it also kind of decodes it for us here in the console. So great, it's telling us the longitude and the latitude of Pittsburgh. This is our city ID. We have a few clouds, that's true. The temperature, this is Celsius, 25.82 Celsius, and so forth. There's just a whole bunch of weather data here. Great. Why don't we look at how we could extract some specific part of this. And let's also look at a way for us to sort of continuously monitor this data. It's going to change slowly, but it will change over time. So if we want to continuously get the output of the weather information, we're just going to make a new function that in response to some command gives us all this data. And then we're going to look at how to extract specific parts of this data. So we're going to use the Max API, and we're going to add a new handler. So that's all going to go inside these parentheses. We are going to say the name of this command. So let's call this get weather. And we won't ask for anything else in the message, so we'll just set up some empty parentheses. And then we'll make a big arrow and a couple squiggle brackets. And inside our squiggle brackets, we're going to just copy the code we have here. So in response to get weather, we are going to, again, look up get all weather and get everything as a JSON. So let's, actually, I'll just comment this out, and all our weather data, it'll only come out in response to this command, get weather. Back in Max, it says hello world because it restarted. And we're going to send this new message, get weather. Awesome. So every time we say get weather, it prints out for us all of the new weather information. So let's pass this information into a dictionary using dict. And let's actually make a metro to constantly update the weather information. So I'm going to make a Q metro. We'll ask for weather information once every second. And I'm going to enable this metro by default by saying add active 1. So once per second, we get a weather update. And if we double click our dict, you can see all the data in JSON format. And you can see how it's kind of organized into these different branches of data. Here is the main category, and then inside of that we have temp. So if we send dict a message that says get main, two colons, and then temp. This outlet, the value for an individual key, should give us the temperature data. So there is our temperature data in Celsius. Now, every time we update the weather data, dict is going to report the name of the dictionary. So if we had a bang here, you would see this getting banged out every time the dictionary gets updated. So let's just use that bang to request the current temperature. So we're taking the bang from an updated dictionary, and then we're saying get temp, which is organized inside of main. And then to isolate this number, we can just use the object root. We'll say root main temp, and then make a floating point number. So there is the temperature in degrees Celsius. It's getting updated once per second. Just clean up our patch a little bit. And looking at our code, this is kind of set to always be reporting the weather data about this zip code, 15201. Let's make a new command so that we can sort of dynamically investigate the weather in different places. And because I don't know the zip codes of everywhere in the world, instead of using the zip code, why don't we try using the coordinates? So just for starters, let's uncomment this line, and I wonder where in the world these coordinates are. This is just what we found in the starter code from the API. Let's paste it into Google Maps. Where is this? Is that? Wow, okay. There. Poland. Let's see what the weather is like in Poland. So let's update the code, and back in Max, you can see the temperature changed. And if we look at the output here, they have a slightly more overcast day than we do here in Pittsburgh. You could also just double click the dictionary and see all that information in here. Great, so that's the weather in Poland, and we are doing that by setting the coordinates using the longitude and the latitude. So let's make a variable for the coordinates so that we can sort of change this dynamically from Max. So where do we set the coordinates? Right here. Let's make a variable called coordinates, and we can start off in Poland. So we'll say the coordinates is the first part of that array, followed by the second part. That should give us the same data. No errors. And if we went and got some other place, how about Mongolia? The longitude and the latitude is these numbers. Oops. Let's copy these numbers and put them into our code. So that should be Mongolia. And it's even colder in Mongolia. You can see the temperature, and you can see all the other data from our weather API. So to make a function where we can change the coordinates, okay, so we're going to make a new function to set the latitude and the longitude. I'll just copy this existing function, and we're going to say the name of this one is set chords, and it is latitude followed by longitude will be the next two parts of this message. And then we're not going to be getting the weather inside this function. We're just going to be changing the value of the latitude and longitude in chords. So we're going to say chords at 0 is equal to latitude, and chords at 1 is equal to longitude. Let's save it, make sure we didn't get any errors, still good. And then inside our get weather function, before we get the weather every time, we just want to update it to whatever new coordinates we might be using. So we'll add a new line of code here that sets the coordinates. And those can be changed with this new message. All right, so back in Max, I forget what our default location is right now. I guess it's still in Mongolia. And we can change our coordinates with this new message, set coordinates. Okay, and let's go to some new location in the world. Where should we go? How about Egypt? So here is the latitude, longitude for this location. Let's copy and paste that. Go back into Max. And this is the new message. We have set chords, latitude, longitude. And here is the temperature in Egypt, 21.4 degrees Celsius. Looks like we've got clear skies. And indeed we are in Egypt. Hooray. Okay, cool. So now we can sort of dynamically set the location with this new message, set coordinates, and the next time we get the weather, it's going to be based on this new latitude, longitude. So to do this dynamically, we could use POC. That's a version of PAC with 2 hot inlets. So we're going to say set chords, and let's see, 40 minus 80. Let's make these floating point numbers. That will be our default location. I think that's pretty close to Pittsburgh, but we can send it new latitude, longitude, and we'll go to some other location. So here's just a kind of random location. 1010. That's in Birim, theoretically. Let's just double check it. 10, 10. Where are we? Cool. Great. All right. So to convert this into sound, the simplest approach to sonification, the kind of like sonification 101 example that you'll always see, is to have some set of data and then use that different data points to control the frequencies of oscillators. So we could start with something like that. This value, it will change over time, but it's not going to change very quickly. So I was thinking we could make a sort of sound installation with many different oscillators that represent the temperature in different locations, and the chord that's created by these different oscillators would slowly change over time as the temperature in these different locations changes over the course of the day, and that would probably relate to the motion of the sun through the sky as well as the time of year. So we want to convert this value, which is degrees Celsius, into frequencies. So in Celsius, 0 degrees would be freezing, and then 100 degrees would be boiling water. So there are many parts of the world that are below freezing. We might want to think of that as like a very, very low frequency. And then we'll just try to find a range that makes sense. So I was thinking we could use M to F if we're going to think about these values as sort of like MIDI pitch values. And let's go somewhere very cold, just for starters. I bet it's cold right here. So Antarctica, these coordinates are these. Let's see what the temperature is down here. All right, so that is -40. I think that's a good sort of baseline lowest frequency. So why don't we just add 41 to whatever temperature we get. And then if we go somewhere really hot, let's see what kind of frequency we get as a result of that. So that's a super low frequency in Antarctica. That's sort of below human hearing. It's almost rhythm, but it's also super cold, so that's okay. Where can we go that's warm? Dun, dun, dun. How about Ecuador? Is it warm in Ecuador? What's the longitude, latitude? Tell me. Okay, it's actually not as warm in Ecuador as I thought it might be. But this is still like, this is a range that's kind of close to the middle of the piano. So let's try this. We are going to, now that we have this max patch working and we can change the coordinates dynamically and convert these into frequencies, let's just use this number to set the frequency of a cycle. And we're gonna, oh my, no, don't do that now. Let's hear this frequency through our speakers. To prevent clipping, I'm going to attenuate this by multiplying it. Okay, so this is the frequency we get in Ecuador, and we could go to different parts of the world just by sending new values to our latitude, longitude. All right, so let's save this. This is weathersounds.maxpat, and I'm going to make a new patch in which we can make many instantiations of this patch and sort of dynamically change the coordinates of each one of them. So I'm going to do this by passing in some arguments to weather sounds. I'm going to say load mess, which loads a message upon the loading of the patch. And we're going to say $1, $2. Those are going to get replaced by the arguments that are given to this patch when we load it as an abstraction. So we can unpack them and put them into those number boxes. Save. And I'll close this. We're just going to instantiate it in our new patch. So if we say weather sounds and then 40 minus 80, that should be Pittsburgh. We can double click it and we can see that those arguments are getting passed in through load mess. Now, little known fact, MaxMSP actually has a web browser built into it, JWeb. And you can set the URL that it's displaying using the URL parameter, which I'm looking at using an attribute inspector. So we could actually go to Google Maps just right here inside Max. And we can find some new locations using Google Maps inside our Max patch. All right, so here's Earth. It's chilling. And we can just pull up some locations by browsing around through here. So this is the latitude and longitude in this area in Russia that we just found on Google Maps. So let's make a new instance of weather sounds. And we're going to give it these two numbers. Now, this is concerning. When you look at this instance, you can see the coordinates are Pittsburgh, 40 minus 80, and this appears to be the temperature. If we look at the dict, however, this looks like it's Mongolia. So it's kind of like it didn't really get the new location. Similarly here, you can see the arguments got passed in, but again, if we look at the dict, it still seems like it's our default location in Mongolia, and they both are reporting the same temperature because these are actually both still getting the default location from our JavaScript code. So what's going on here is that the load message instantaneously outputs these numbers and then creates this message. But node.script actually, it takes a second to start the script running. So this message is getting passed in before this object is ready to receive it. So what we want to do to make this work properly is wait for this thing to get loaded and then get these numbers. So back in our JavaScript, remember we had this message, hello world. This gets sent out the Max outlet as soon as the JavaScript starts. So we could use a message here to bang out those numbers that we want. And that way we'll get the numbers after this has started running. So I'm just going to change this to say start right here as soon as the JavaScript starts running. Let's look at our Max console. And when we start the script, we actually get a little error message here because the dict doesn't know what to do with that message start. The dict wants to get these messages that just say dict and then the name of this like chunk of memory with the JSON data. So what we're going to do is we're going to fix that problem using root. We're going to say root start. We'll take output of node, and here we're going to get everything that doesn't begin with the message start, and that'll set our dictionary. And then we're going to just take the start message and use it to rebang the message from load mess. And let's clean up that patch so that it's not flying on top of everything. Okay, so this is going to load the JavaScript. It'll take the start message and then use it to hopefully rebang out these coordinates that we're specifying. So let's save this. Going to delete these and then bring them back. Cool, so this is actually working now. Here we're getting 40 minus 80. We can look at the dict and you can see that these are indeed the coordinates that we've specified. We're in the United States. And it's actually a very warm day today, so we're getting this nice high frequency. And then over here, we are in Russia, where it is super cold, and we're getting, this is actually a really low frequency. So we're hearing two different tones. One is much higher than the other. So let's just add some different locations to build up this sound installation. And I'm going to also add just a couple more features to make this interaction a little nicer. Let's make it so the instantiation of this patch fades in slowly at the beginning. So right here we are attenuating everything by some value. Let's make a line tilde to set the attenuation value. So it's going to override that. We'll make a load bang and a message. And we'll say 0.33 is the amplitude that we want to rise to, and let's do it slowly over the course of 10 milliseconds, or 10 seconds, which is 10,000 milliseconds. So that'll make it slowly fade up when the instance is created. And let's also make it slowly change this frequency. So these temperature values, they're not going to change very fast because in general, temperature does not change very fast. But when it does change, we're going to create a ramp to set the new frequency slowly. So again, we'll use a line tilde to do this at audio rate to set the frequency. And we're going to take this frequency value and let's use pack. So we're going to pack together two numbers, where the first is a floating point number, which is going to be the frequency, and the second number is the ramp time for line tilde. And when I save it, you can hear these two patches are kind of slowly fading to their frequency value. So let's just add some new locations. How about Indonesia? The coordinates here. We'll make a new weather sounds and paste in these coordinates. There's no comma. Let's add Australia. Ethiopia. Let's just get that place in Ethiopia. So there you go. That's like a real simple sort of sonification project that creates an evolving harmonic sound piece based on the temperature of these 5 different locations. And this is really the simplest possible thing we could be doing with some data, is just taking that signal that's going up and down and mapping it to control the frequency of some sine waves. So if you wanted to do fancier stuff with this, you could use this as a starting place. For starters, you could at least, maybe make some of these move to the left channel of the stereo panorama or the right channel, and maybe you could do that based on their east-west position in the world. You could look at other aspects of the weather data, because we have many other things like pressure and humidity, and you can use that to control things like timbre or further sound processing on the signals that you're generating. Wind speed would probably be interesting as well. Okay, so we're going to be sharing this demonstration in the Google Drive. Check out that link if you want to build further upon it. One last thing I want to say about sharing these projects that are made using Node.js. When you're sharing this with someone else, for example, if you're a student in this class and you're going to share the whole folder of stuff with us, you don't want to generally share this folder node modules. You want to let the user install the modules themselves, because they're going to get the modules that work on their particular system. So if you wanted to send this to somebody, I would suggest, maybe making a copy of the whole directory and getting rid of this, and then sharing this directory rather than one that includes node modules. And for the person who receives it and they're going to run it in Max, they can actually install those modules directly in Max without even going into the terminal, by adding one more message here, which is script npm install. So if we just pasted that, this is a one-time thing. The very first time that someone wants to use this patch, they send this message. So once they send this message to node.script, it's going to create their own folder for the node modules, and all the things that are going to run appropriately on their machine will get installed there. It also is going to make your directory a lot easier to copy around, because there are just a ton of files that are inside these directories. So if you don't have to deliver all of them, then don't do that. Okay, so that's our first demonstration of data sonification using Node.js inside Max. Stay tuned for more. Thank you for joining us. We'll see you next time. Peace.